Hey everyone, this is Richard. Hey, I got a new system here, so hopefully the audio will be better. Maybe the video will be better. Maybe it'll be worse. We'll have to wait and see. But it's new, all right? And I'm back on Visual Studio on Windows because I'm going to be using this for a little bit more complicated things in the near future. And it will be helpful to use Visual Studio itself. So let's right now talk about asynchronous programming, and let's go over task. All right. So what is asynchronous programming? So when you have some tasks, one in the row, how synchronous programming, what we've been doing before is you finish the first task, finish the second task, finish the third task in that particular order. But what if finishing one task takes a long time? Well, for the second task to run, you're just going to sit there and wait, right? So you're going to wait, and then it's going to be a delay, and then it's going to be a delay, and that leads to something called latency. So there's a greater latency to get the results just because you're waiting and you're being blocked by something that's taking its sweet time. For example, let's take a real life example. Let's just say I'm baking a cake, then I'm tying my shoe, and I'm signing a signature. Okay, so if we do it in that order, I bake the cake, I wait for the cake to bake, then I tie my shoe, and then after I tie my shoe, then I'm going to sign a signature. Maybe sing a song instead of signing a signature, okay? So while I'm doing that. So when you think about it, why do I have to wait for the cake to bake before I tie my shoe, right? And why can't I tie my shoe and sing a song? I'll finish tying the shoe and then finish singing the song, and then the cake will finally be done, right? So you're starting it in one order, starting the cake first, starting tying the shoe, starting the singing, but they end at different times. And you want to return the result, like the cake, the result of the shoe being tied, and the result of the song being sung. You want to return them as soon as they're finished, not in a particular order. That's what asynchronous programming is. It's different from parallel programming. Parallel programming is getting a certain amount to function, getting a certain amount of data, information to be processed in a faster manner because you're processing more data at any given time. So that's a little bit of a different than asynchronous programming. Okay, asynchronous programming is not processing more data. It's simply just making there less latency, making the system more responsive. Okay, so let's do this in code. So we have void first step. All I'm going to do, first step, second step, third step, all I'm going to do is have a task.delay. So all I'm going to do is just delay and just wait, and then it's going to print first, print second, print third. So task.delay, so this is a static class, right? Delay 2000, so that's in milliseconds, so that's 2 seconds, and then it's going to wait. Wait for it before it goes to the next line, all right? Same here. So what should happen is first step, second step, third step. If we did it in synchronous programming, standard programming, right? We would wait 2 seconds, it would print first. Wait 3 seconds, it would print second. And wait 1 second and print third, right? So that'd be a total of 6 seconds before it's done. But what if we did asynchronous programming, right? So this would probably finish first, this would finish second, and this would finish third. And how long would it take to finish all three? Probably close to about 3 seconds, right? So it's at half the time because they complete as soon as they complete, okay? So what I'm going to do is here, I'm going to call all the methods, and I'm just going to say first step, second step, third step in a synchronous fashion. Then I'm going to go next and do task, okay? So task is a new keyword that we haven't learned yet. We're going to do void task. There is a task T result, but we'll do that some other time in the future. Now, we'll talk about start, new, and run. These are different ways of starting the task itself. So right now, we instantiate the task, first task, second task, third task, okay? And there's different ways of doing this. I can't figure out why there are different ways to do it. I'm sure there is a reason, but I looked into it and I couldn't really figure it out. So for practical purposes, for my purposes, it doesn't really make a difference what we actually do, how we actually have the first task, how we actually start the tasks themselves, all right? So the first task, I'm going to say task, again, this is all the same. It's just different ways of doing it. Task.factory.startNew, and then you put the name of the task that you're going to start right here. And as soon as you go, the program hits this, it will go ahead and start this task. The second one would be Second task, new task, second step. This one is not actually starting. It's just you're making the object and that's it. So you do have to do second task.start. That's just the way it is, okay? Third task is going to be task.run, and it's going to be third step right inside here, right here. Again, why? And so we're starting in order. First, actually third and second. That's how we're going to start it. But why is it that task.factory.start new compared to task.run? I'm not sure again. We'll see probably sometime in the future. And then I'm going to go ahead and run first task, second task, and third task, wait. What does that actually mean? There's some stuff down here. I was going to make a new program. First task, second task, third task. What can actually happen is your program can finish before these results return. Okay, so what can actually happen is your program will run, and maybe it'll run, and then before it can wait, so it's finished running, and you still haven't gotten the results of the first step, second step, third step. And if it finishes running, it just ends. And so this will never be accomplished. There's no way for the system to know to wait up. Don't finish the program yet. We have some information coming unless you put first task.wait. Now, you don't have to put all of them down. You could just go, what's the longest waiting one? Second step, and just put second task.wait, because what's going to happen is first task and third task is going to finish first. So all you really need to do is wait for the longest one. The problem with that, of course, is what if you're wrong? What if the first task finishes last, and then second task result will come back, but the first task will not be run, will not be activated. Okay, so that's the problem. Always, whenever you're going to put a task in, always make sure to wait for it. All right, so let's run this. What should happen? We should wait 2 seconds, types in first, 3 seconds, types in second, 1 more second, types in third. Then it's going to kick down to here, and it's going to say, run them all at the same time. Then it's going to say third, first, and second. That's what should happen right here. Okay, let's see what happens. Okay, first, it's waiting, and 1 second. Okay, then it's going to run again, first and second. So that's how it actually runs, because they're returning in different orders. Now, just like we said, what about if we remove first task.wait? Okay, so we're just going to wait first task. What's going to actually happen? I'm going to remove this part too. So what should happen is, if we just look at it, because this is a simple program, we can tell what's going on. Much larger programs, we can't always. So for here, what's going to happen is it's going to activate all of these tasks. And then what's going to happen is this is going to print first, this is going to print second, and then the program is going to end. Second step will not activate. So let's see what happens. Third, first, right? So second did not activate because the program ended before the second step could actually finish. So we should put second step.wait. We should put third task.wait anyway. Okay, so I think that's about it. I hope it was helpful with learning the tasks and just the concept of asynchronous programming, because we'll use that in the future, okay? Thanks.